Section 5.1 is on perpendicular and angle bisectors. So we are going to start off here with a vocab word. It's equidistant, and that is when a point is the same distance from two or more objects. So kind of self-explanatory there. Equa means equal, and distant means the distance. Then we're going to look at a couple of theorems. The first one is the perpendicular bisector theorem. And that is saying that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So in other words, in a triangle like this, our point is here, and then it is the same distance away from the other endpoint. So then these two segments are congruent to each other. And the converse of that is saying that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if it's the same distance from that point into the middle and the same distance in here, then this is on the bisector, the perpendicular bisector. And then that proves that this is a 90-degree angle as well, because it's perpendicular. All right, another vocab word is locus. That is a set of points that satisfies a given condition. Example 1 here says to find each measure, and they're asking us to find the length of YW. So YW is right here. And we just talked about the theorems that if we have a perpendicular bisector, that the two sides are the same. So YW is the same as XW, and XW is 7.3. So therefore, YW has to be 7.3 as well. These two sides are the same. And then here we need to find the length of BC. So BC is this full length here. And BC is the whole length. So BD is half and CD is half because of that perpendicular bisector right there. And if DC is 16, then so is BD. And BC needs to be 16 plus 16, so it would be 32. And then for part C, we need to find the length of PR, and PR is right here. And we know that this side and this side are congruent to each other, so we can set up an equation here. 2n plus 18 is equal to 7n minus 18. And I'm going to subtract 2n because we want to move the variables to the same side first. And I'm going to add 18. So that's 36 equals 5n. And then we have to divide by 5. So n would equal 7.2. So then I have to plug that back into the 2n plus 18 times 7.2 plus 18. This would be 14.4 plus 18, and that would be 32.4 when we add them together. So that length is 32.4. Then we're going to have the distance and angle bisectors theorems. The first one is the angle bisector theorem that says if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So if the point is right here at C, then this distance here and this distance here are the same. And then we have the converse of angle bisector theorem that says if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. So if there's a point here, which is at C, and these two segments are already given that they are equal, then that proves these two angles are equal. So we need to find the measure of LM here in this picture. So LM is right here, and we were just told that these two sides would be the same because of the angle bisector theorem. So if that top JM is 12.8, then ML or LM is 12.8 as well. And then we have this one that says, what is the measure of angle ABD? So that is this angle right here. Given that the measure of angle ABC, which is this whole angle right here, is 112. So this bisector here, this DB, is cutting that angle in half. So we would have to take 112 and cut it in half, which would be 56. So the measure of that angle would be 56 degrees. And then here, the measure of angle TSU, which is this one here. Again, similar question, only we do not know the entire measurement this time, but we know that the one angle is 5z plus 23 and the other one is 6z plus 14. And we do know that those two angles are equal. So we can set up our, set up our equation here that these two are equal to each other. So our first step is to get the variables on the same side. So I'm going to subtract 5z from both sides. And then I will have to subtract 14 from both sides. So z would equal 9. And then I have to plug that back in. So I have to do 5 times 9 plus 23. And that would be 45 plus 23, which would equal 68 degrees. And our last example here says, write an equation in point slope form for the perpendicular bisector of the segment with endpoints A, -1,6, and B, 3, 4. So your first thing that you need to know is point slope form. We need to have a refresher on that. And M is our slope. And then x1, y1 is an ordered pair from that line. So step number 1 is to graph. I have already done that for us here. Graph your points and then find the midpoint would be step 2. So our ordered pairs were -1, 6 and 3, 4. And remember the midpoint formula is x1 plus x2 divided by 2. Don't want that there. Comma y1 plus y2 divided by 2. So we're going to find that ordered pair. So we're going to add the two x's together. So that would be -1 plus 3 divided by 2. And that would be 2 over 2, which would be 1. And then we would have to do 6 plus 4 divided by 2. So that would be 10 over 2, which would be 5. So the midpoint is 1, 5. So that's already graphed here. So as of right now, we were given this point, and we just found this point. So now we're going to have to find the slope of that line so that we can find the slope of that perpendicular line that's drawn there. So again, we're going to use those same ordered pairs. And the slope formula is y2 minus y1 over x2 minus x1. So I'm going to have 4 minus 6 and 3 minus a negative 1. So I'm going to end up with negative 2, and 3 plus 1 would be 4, so that would be negative 1/2. Now, remember, perpendicular slope is that we flip this fraction, so it would become 2 over 1, and then we make it opposite. So this one, the negative 1/2, that was negative, so our perpendicular slope has to be positive. So that's 2. So our slope of our perpendicular line is 2, and we know it's going through that point of 1, 5. So we found that midpoint, and we found the slope of that other line. We're talking about this one right here. So we know it goes through 1, 5, and its slope is 2. So now we can write our point slope form here. So the slope was 2, and x value from that ordered pair was 1, and the y value from that ordered pair was 5. So there is the formula for that line.